section 5.5, and it's called Solving Quadratic Equations Using the zero factor property. All this is pretty much telling you is that you factor the equation, make it equal to 0, factor, and then set the factors equal to 0 to solve. So this is what the zero factor property says, or is defined by. The zero factor property just says if two numbers have a product of 0, then either one of those numbers or both are 0. So I'll show you an example. Example would be to solve 8x plus 3 times 2x plus 1 is equal to 0. So you know how to factor. You could have factored that yourself. But the new part is, this is old, asking you to factor. We already went through that. The new part is making this equal to 0. If it's equal to 0, all you do is you set each factor equal to 0. So 8x would be -3, and x would be -8/3, or -3/8. And you do that for both. 2x plus 1 is 0. So 2x is -1, x is -1/2. That's pretty much the whole section. In order to finish this section, there's a couple more things I want to mention, and then we'll just kind of plow through the rest here. There's something called standard form of a quadratic equation. Standard form of a quadratic equation would be ax squared plus bx plus c is equal to 0. We talked about this when we were factoring. I told you you multiply a and c together, and b would be the number in the middle. Something else to talk about is called the fundamental theorem of algebra. Fundamental theorem of algebra says you will get as many x-intercepts, roots, or zeros as the highest power of x. And the last thing before we get into like actually doing this is at this level when we're solving equations, you want to make sure you set equal to 0. When we get to these more complicated equations, you want to start by making them equal to 0 and then factoring to solve. So let's go ahead and talk about solving equations a little bit. When we're solving equations, generally, first thing we try for is if they're basic, we just go ahead and do it. Like if it was x plus 2 equals 0, we don't have to do anything complicated. You just bring the 2 over and you get x is equal to -2. That's fine. But if you have a power higher than 1, like if it's quadratic, then what you would do is you would factor and set the factors equal to 0 to solve. And when we're going to factor, we're talking about GCF, we're talking about grouping, trinomials, and special cases. Generally, we do this if it's like x to the first power, we just solve it. But if it's x to the second or x to the third, we use more advanced techniques. So let's go ahead and get started with this. The directions for these problems are just going to ask you to solve. And let's say we wanted to solve 3x squared minus x is equal to 4. Remember what we said, we want to make it equal to 0. So 3x squared minus x minus 4 equals 0. And then we just go ahead and factor. So what we're going to do is we're going to do 3 times -4 is -12 and add up to be -1. We're not using -4. We multiply the first times the last number. So this is 3 times negative. Oh, I'm sorry. Were you giving me the answer? I misheard you. I'm sorry. So George is saying 2 numbers that would make this happen. Would be 3 and -4. So it's just like we've been factoring for a couple classes now. We're going to factor this too. 3 and -4. So we have 3x squared plus 3x minus 4x minus 4 is equal to 0. Cut it down the middle. Take out a 3x, we get x plus 1. Take out a -4, you get x plus 1. So factored, we'd get x plus 1 times 3x minus 4. What we do is we set the factors equal to 0. At this point, this is like the new step. And we get x is -1. 3x is 4. So x would be 4/3. So we get two different answers. You see how everything builds, right? We talked about solving equations, then we talked about factoring, now we're doing this. It's kind of like this is all just one big snowball you're throwing down a hill, right? Everything just keeps building on what we already know. Let's see here. Next problem, what if we had something like this? So we had 16m squared is equal to negative 24m minus 9. Just like before, you don't want to start doing this. You're like making up your own math if you do that, right? What we want to do is we want to make sure it's equal to 0. So let's go ahead and do that. 16m squared plus 24m plus 9 is equal to 0. There's a couple different ways we could solve this. We could do the x thing, but I did teach you an optional like factoring thing here. Does anyone see something we could use to factor this a little quicker? Well, yeah, right. This is just 3m squared. This is 3 squared. Or I'm sorry, this is 4m squared. And if we do 2 times 4m times 3, that gives you 24. Well, I'll show you two different ways to do this here. If you recognize that, it's really fast. It would just be 4m plus 3 to the second is equal to 0. That's how we talked about factoring that. Yeah. But you have to make sure that 2 times a and c gives you the middle. Does that make sense? Yeah, so if you do that, if this is positive, then this is positive. If it's negative, then that's negative, right? So what I did is I always want to solve equations where they're equal to 0. So I switched the signs. I added 24 to get it on the other side, and I added 9 to get it on the other side so that it's equal to 0. Does that make sense? So I understand. Let me just show, I didn't show one step, and that's my fault. Let me go ahead and just show that missing step. I always want it to be equal to 0. So if you add 24m here and add 24m here, and then add 9 and add 9, you get 16m squared plus 24m plus 9. Does that make sense, Evan? So now it is equal to 0. That's what we wanted. Once we get it equal to 0, you could factor by using that shortcut. If you go ahead and take the square root of both sides, you just get 4m plus 3 is equal to 0. 4m would be negative 3, and m would be negative 3/4. Another way to do it, if you don't want to memorize that formula, I told you all along you don't have to memorize it. You could also just do 16 times 9, which is 144, and add up to be 24, which is 12 and 12. So if you want to just do it the way we talked about with trinomials, this would be 16m squared plus 12m plus 12m plus 9 is equal to 0. You go ahead and take out 4m, you get 4m plus 3. take out 3, we get 4m plus 3. So either way, you get exactly the same answer. 4m plus 3 times itself is the same thing as just squared. So you get the same answer. M would be negative 3/4, and you'd actually get it twice. All right, so we get the same answer there. Last page of my notes. All right, let's keep this going here, and let's solve. The problem on the test is going to look like this. All right, it'll look very similar to this. So what you want to do is just make it equal to 0 and then factor, set those factors equal to 0. Okay? No surprises. I just want you to know what I taught you. That's it. Let's keep this going. What if we had 2x squared plus 24x is equal to 0? It's already equal to 0. If you go back to the recipe we had up here, I'm just going to do a little copy and paste. This is what we said. This is how we solve equations. So you always want to go in this direction. This is not a basic equation. So let's try to factor it. First step of factoring is GCF. Is there a GCF here? So what we could do is we could write 2x times x plus 12 is equal to 0. Now what we do is we set these equal to 0. Right? Just like we did before. Once you factor it, you set the factors equal to 0. If you divide by 2, you get x is 0. And if you subtract 12, you get x is negative 12. All right, let's try something else. What about 5x squared minus 80 equals 0? It's not a simple equation. So let's try to factor. Is there something we could, is there a GCF in both of these terms? You take out a 5, and we're left with x squared minus 16. Now you want to set the factors equal to 0. So 5 doesn't equal 0. That doesn't make sense. But we could set x squared minus 16 equal to 0. That's the same thing as x squared minus 4 squared. So this is a special case. X plus 4 times x minus 4. If we set those equal to 0, we just get x is negative 4 and x is positive 4. The 5 doesn't matter. We're just looking to solve for x. The 5 in front doesn't matter. All right. How about something like this? I have 3 more problems to finish out the night here. What about if we had x plus 6 times x minus 2 is equal to 2 plus x minus 10? On the test, I told you that there were 2 problems that we'd go over tonight. I told you the first problem was that factor problem we just did. The second problem on the test looks like this. All right. The way you would solve this is you want to make sure that you factor completely. So let's go ahead and distribute, and then we'll get everything equal to 0. This would be x times x is x squared minus 2x plus 6x minus 12. So on the test, you want to make sure that you distribute everything, then combine like terms, and then get it equal to 0. So some of these problems take a little more work. So let's go ahead and factor this. We're looking for numbers that multiply to be -4 and add up to be 3. -104. This would be x squared minus x plus 4x minus 4 equals 0. Cut it down the middle. You take out an x, and we get x minus 1. Take out a 4, and we get x minus 1. And this would be x minus 1 times x plus 4. Setting that equal to 0, we get x is 1, and x would be -4. A couple more problems here. And let's say we had 12x is equal to 2x to the third plus 5x squared. Well, again, just like before, you want to make sure it's equal to 0. So I'm just going to bring the 12x on the other side. And we get 2x to the third plus 5x squared minus 12x is equal to 0. All right, so just going back to our menu from before. This isn't a basic equation, so let's just go ahead and work our way through the list. Is there a GCF we could take out of the whole thing? Yeah, the 2x, right? Or not a 2x, just an x, right? So if we take an x out of the whole thing, now we set the factors equal to 0. That's what the rules are. So we're going to make x equal to 0, and we're going to say 2x squared plus 5x minus 12 equals 0. So here's one of the roots. And remember, we're supposed to get 3, right? Remember we said that earlier on? You're supposed to get however many x-intercepts is the highest power of x. Now we could just factor this. So what are numbers that multiply to be negative 24 and add up to be 5? Very good. Negative 3 and 8. You know, we're doing really good at factoring. So 2x squared minus 3x plus 8x minus 12 is 0. Cut it down the middle, take out an x. We get 2x minus 3. We could take out a 4. We get 2x minus 3. So factoring like we always do. And then setting the factors equal to 0. And then this one. All right, we're supposed to get 3 roots, and we did. By the way, when I say roots, a root is the same thing as an x-intercept, which is the same thing as a 0. This is like if you had x is equal to negative 4. That's what a root means. A root just means what's x equal to. When we say factor, factor would mean if it's equal to 0. So x plus 4 would be a factor. You get the root by setting the factor equals 0. Does that make sense? It's just like a subtle thing, but you should know the difference. All right, and the last one for tonight. We'll finish on a high note with a word problem. I expected somebody to groan. Nobody likes word problems. Let's say the length of a room is 2 meters less than 3 times the width. The area is 96 square meters. Find the width. The way I would do a problem like this is draw it out. So we have length and width. And according to this, it's saying that the length is 2 meters less than 3 times the width. So how can we write that out? The length is 2 less than 3 times the width. So 3 times the width minus 2, right? Area would be length times width. And the area would be 96. And that would equal the length times the width. All right, so what I would like you to do is just multiply it out and make it equal to 0. And if we do that, we get 96 is equal to 3w squared minus 2w. Bringing the 96 over. And then we just have to factor and set that equal to 0. So you guys could really finish this. The numbers are a little bit bigger, but we're looking for numbers that multiply to be 288 or negative 288 and add up to be negative 2. And just to save us a little bit of time, it's negative 18 and 16. So let's just go ahead and finish this up and then we could go home. This would be 3w squared minus 18w plus 16w minus 96. Cut it down the middle. We could take out a 3w and we have w minus 6. Take out a 16, w minus 6. And factored would be w minus 6 times 3w plus 16 is 0. W minus 6 would be 0, so w is 6. And for this one, 3w plus 16 is 0. Bring the 16 over, and w would be negative 16 thirds. One of these is incorrect. Does anyone know what the wrong answer is? Yeah, you can't have a negative width. Sometimes when you're doing these word problems, you'll get an answer that's negative, and you just say that that doesn't make any sense. So if the w is 6, the length is 3w minus 2. 3 times 6 minus 2. 18 minus 2 is 16. Right, so we have the width, we have the length.